After defining the chilled water plant baseline operating characteristics, we can define measures related to the chilled water plant for the specific project. For our example building with Chiller 1, defined in previous tutorials, there's a worksheet called Chiller ECM, where we can define the energy conservation measures to apply to the chilled water plant related to Chiller 1. There's an ECM worksheet for each chilled water plant that's defined on the equipment worksheet. First, let's look at the chilled water pump VFD measure. This relates to adding a VFD to an existing pump or restoring operation of an existing VFD. First, you want to document the baseline condition in the user documentation section, shown to the right. It shows that the chilled water pump has a VFD, but it was found in bypass mode. And see the chilled water pump VFD and bypass worksheet for a picture of this condition. Screenshots and trend data to support the as-found operation could be added to the doc template worksheet right here. This worksheet can be copied and renamed as desired. In the case of our example project, we've included a photo of the pump VFD control in bypass mode right here. This helps to document baseline conditions. So going back to the ECM worksheet, let's input some information about the measure characteristics, namely the VFD drive efficiency and the pressure set point. Let's go ahead and enter that here, and the set point, let's say, is 20 feet. The measure assumes that the pump VFD speed will be modulated to maintain the pressure set point in the piping system. Remember that the help menu is accessible from this screen by clicking on the question mark in the gray box in the upper right hand corner. The help menu includes detailed information on each of the inputs in this worksheet, shown here. So now we'll check the box next to the VFD measure, click Calculate, and then we'll wait for the tool to do the calculation. Now we can look at the results. On the Summary by Equipment worksheet, we can see the energy usage by piece of equipment. You can see the electric usage per utility period. Note that the winter peak period usage is 0 as expected because this period was not included when we defined the utility periods. Let's take a look at that electricity rate worksheet. You can see there's no hours in the winter peak period. That's why that's 0. You can see the utility rates tutorial for a discussion on time of use periods. For buildings with Saturday or Sunday operation, you'll need to run the tool twice because the gas and electric utility schedules assume that all days are the same, while most utility tariffs use off-peak rates for all hours of the weekends. The usage values shown on this worksheet can also be compared to usage values estimated using other calculation methods outside of the CBOA tool, such as end-use estimates. For example, if you've estimated that the cooling energy for a building is 10% of the baseline whole building usage, how does that compare with the baseline usage number estimated by the CBOA tool here? The Summary by Measure worksheet shows the estimated energy and demand savings on a per measure basis. For our example measure, it shows energy savings during the 5 time of use periods that have hours associated with them, but 0 for winter peak, since that's not a part of the time of use period for the utility tariff for this example project. But it shows 0 peak demand savings since the pump would probably operate near full speed during peak demand conditions when it's warm outside. Remember, this is a chilled water pump. In fact, there is a slight demand penalty due to the inefficiency of the VFD. This peak demand savings is reasonably close to the deer period peak demand savings. And note that even though the peak demand savings is slightly negative, the measure sees positive annual demand dollar savings due to the demand savings during off-peak periods, especially in the wintertime. The annual demand dollar savings is calculated by the tool using the monthly demand savings estimates, not the annual peak demand savings. In addition, on this worksheet, you can put in the implementation cost of the measure to see the simple payback. Let's assume that the total cost of adding the VFD to this pump is estimated at $20,000. Let's go ahead and input that. We see that the estimated simple payback period for the measure is 3.6 years. Returning to the ECM worksheet, other ECMs can be added for chilled water supply temperature, condenser water supply temperature, and cooling tower fan VFD measures. For our example building, we'll assume that each of these ECMs is being added to this particular chilled water plant. We will add a chilled water supply temperature reset strategy. So we'll click on reset here, resetting the temperature between 45 degrees and 50 degrees based on outside air temperature. So let's enter in those outside air temperatures, how we estimate the system is going to operate. We'll also add a condenser water supply temperature reset based on outside air wet bulb down to a minimum temperature of 75 degrees. Finally, we'll add a VFD to the cooling tower fan, converting it from single speed on-off to variable speed. So let's go ahead and enter a drive efficiency here. And when you're adding these ECMs, be sure to check the boxes next to the ECM details, the input fields, to indicate that you'd like the tool to model this ECM. So now to calculate the savings for all of these measures, we will click on the Calculate button. And after it's finished calculating, we'll go to the Summary by Measure worksheet to view the savings estimates. The savings for all the measures is about 150,000 kilowatt hours, which we can see by highlighting the cells and looking down in the lower right hand corner of the Excel screen, and 17 kilowatts, actually 18 kilowatts. Note that these savings are calculated from a common baseline. The tool shows the estimated savings for each measure as if they were implemented on their own without the other measures. Now the tool is capable of estimating the savings in consideration of the other chilled water plant measures by using a rolling baseline or stacking the measures. And the reason that it's not totaling the savings on this is because these measures were evaluated in a non-stacked fashion. So let's go back over here, and by stacked we mean that the proposed case of one measure is used as the baseline case of the next measure evaluated. Let's take a look at the help menu on this topic. By going here to the introduction part, stacking and ECMs. For the chilled water plant, the measures are evaluated in the order shown here: chilled water supply temperature, condenser water supply temperature, and then chilled water pump VFD, and finally cooling tower fan VFD. And this order cannot be changed. The order of the stacking cannot be changed. So let's check this box here to stack the measures and recalculate the savings. It's good to stack measures in order to help minimize double counting of savings and to give a better overall picture of the total savings. So returning to the Summary by Measure worksheet, now the estimated savings is about 148,000 kilowatt hours, which is slightly less than the non-stacked savings of 150,000, and also the demand savings drops from 18 kW to 9 kW from non-stacked to stacked. Note that this worksheet now totals the savings for all the measures, and it allows the user to input the total project cost. For example, if the total project cost of these measures was $40,000, let's enter it here, the total project payback period would be 2.8 years. Adding utility incentives right here would bring the net project payback period down. The stacking button only stacks the measures associated with the cooling plant on this worksheet. It does not account for any air handler measures that are chosen. For example, if you were proposing implementation of air handler measures that reduce the overall cooling load, for the chiller plant measures, you would want to enter the estimated chiller load profile of the system after implementation of the air handler measures, since the cooling plant savings associated with the air handler measures would be accounted for in the savings related to those air handler measures.